So if we continue the previous problem, but only slightly change the mass of the box, we have the same force being applied of 20 newtons to a 60 kilogram box, and we want to know how far does the box move every 3.86 seconds. Well, if we apply a constant force, then the object will have a constant acceleration. So if we can figure out that constant acceleration, we can then use that in kinematics to determine what is essentially delta x, how far the box moves. In this case, we're going to assume that there's no friction on the box, slowing the box down. So we're going to start off by just considering the 20 Newton force that's being applied and the other general initial conditions that we know. For example, we know the mass of the box, we know the time that it's going to be moving, remember, in general, we can assume that the box will start from rest once the worker applies the force. So we need to find the acceleration. From the acceleration and the other initial conditions, we can determine how far the box will travel. The acceleration is just going to be equal to the force divided by the mass. In this case, 20 newtons divided by 60 kilograms, and you find that you have an acceleration of 1/3 meters per second squared, or 0.333 meters per second squared. We can then take the fact that we know something about the acceleration and the time and the initial velocity to determine how far the box will slide after 3.86 seconds. So again, just writing down what we know. And now we're looking for delta x. So using the second kinematic equation, we know that the initial velocity is 0 because the box starts from rest. We know the acceleration from the force and the mass, and we know the time. We know the acceleration and the time, so we can determine the distance that the box will travel.